Hello, ladies and gentlemen. Hope everyone is doing well today. So, last time we met, we finished up with chapter 6, which was confidence intervals, and we're going to see it pop up again a little bit later in this chapter, which focuses on hypothesis testing. And this is one of the crucial tools that statisticians use in order to make inferences about the population from the experiments that they conduct. And before we actually get into the math behind this particular concept, it's a good idea to try to get a good understanding of the vocab behind this particular section. So in case you may have forgotten what a hypothesis was, completely fine, because we're going to go over that in good detail today. So back in your science classes such as bio or chem, you may have used a hypothesis before in your scientific process. And essentially what it was a claim or an assumption of something that you were about to conduct in an experiment. And it's the same sort of concept when it comes to stats, except this claim or assumption is going to focus on a population parameter. As you saw before, population parameters could be the mean, they could be a probability of success, or variance/standard deviation. Right? And there are going to be two types of hypothesis that are focused in hypothesis testing. The first is what's known as a null hypothesis. And all it is just a statement of equality. So saying something that the mean of basketball scores in a game is equal to 10 or is equal to 75. So it has a strict equality statement behind it. And an alternative hypothesis is essentially the complement to it. So you still have a statement in mind, but this time rather than being of equality, it's going to be of strict inequality. So something where it could be not equal to, it could be less than, or it could be more than a particular value that you're working with. Now, the other key feature about an alternate hypothesis is that it's true if the null hypothesis is false. And what we'll do to abbreviate them is we'll call the null hypothesis H sub 0, and we're going to call the alternate hypothesis H sub A. So that way when we abbreviate the statement, it's true if H sub 0 is false. Okay. So first step that really comes into play with these types of questions is just identifying what your null hypothesis is as well as your alternate hypothesis. And a good way in which we can approach this problem, or these types of problems, is to identify some keywords as well as some notation. So, as I mentioned earlier, you may have a null hypothesis where it says that the mean is equal to some number k. So I'll put in parentheses that k is a number. So it could be like 5, it could be 10, 250,000. And when you read a word statement, or just a statement, of a null hypothesis, it could say something like the mean is that particular number k. So the word is going to be a key component when it comes to the null hypothesis. Now, on the contrary, when it comes to the alternate hypothesis of the statement, you can say that the mean mu is not equal to k. So going back to our words, you can say the mean is not, or sometimes they may use isn't, k. And that'll be a good indication to show that we're using not equal to. Okay. Now the other types of inequalities that may pop up could be greater than or equal to k. And some key words that you may have seen already. So this relates to at least, as well as mu is less than or equal to k, in which case you're dealing with at most. Likewise with the alternate hypotheses, rather than including the equal sign here, we're going to say that mu is less than k. Because if mu is greater than or equal to k for the null, that means we're going to use the opposite inequality without the equal portion on the bottom. And some key words here, if mu is less than k, we can see less than as a possibility for words, or fewer than. Vice versa, if we deal with at most, that means mu is going to be greater than k. So greater than k is a possibility, as well as more than. So it's going to be key to identify what types of words you have to see which ones are going to relate to which specific equality statement, whether they be strictly equal or strictly unequal. All right. So we'll take a look at a couple examples together. So here we say that a medical company states that the mean time for a patient to recover from the flu is at most 14 days. And so all that we want to do is just to identify what the null hypothesis and the alternate hypothesis are, and then which is the claim related to this statement here. Well, we know for one that our population parameter is the mean, right? And we know that we use the Greek letter mu to represent the mean. So here, if we're dealing with at most, this tells us that mu has to be less than or equal to 14. Because that's what they're saying over in this statement here. Now, the complement to this, or the alternative hypothesis, is just to use the other inequality, pretty much the opposite of this one. So the alternate hypothesis is stating that the mean recovery time is going to be more than 14 days in this particular example. And what they mean by the claim is you're just identifying which hypotheses was written first based off of this example. So since they listed at most 14 days, that told you that you had to use the less than or equal to sign for your null hypothesis. And so this is the claim that they have for this particular example. So you just relate which words tell you the first hypothesis, and that in turn is going to be your claim. In taking a look at the second example, let's say that Amazon announces that the mean cost of its new Kindle Fire is less than $150. So same sort of process as before, we would just want to identify the null and alternate hypothesis. So because we are dealing with less than this time, we're dealing with a strict inequality. So mu is less than 150, and since we got that info from our word problem, that tells us that the alternate hypothesis is the claim in this case. Whereas the null hypothesis is going to be the opposite. So we're saying that the mean cost for this new Kindle Fire is going to be at least 150 according to our null hypothesis. Okay, so this is essentially what the first part of the first section focuses on. It's just identifying what your two hypotheses are, and then from there identifying which is going to be the claim. So your assignment for today is just going to deal with those types of identifications when it comes to word problems. Tomorrow we will go over those types of examples as well as possible errors when it comes to these two hypotheses. And as always, these notes will be available on Google Classroom. In case you have any questions, feel free to email me, and I hope you have a great rest of the day.